Hello everyone, welcome to our channel Python with GEC Bharuch. Today I will be introducing you to Seaborn, one of the most popular data visualization libraries in Python. So Seaborn, we will be exploring Seaborn, a powerful and versatile library for data visualization in Python. So whether you are a data scientist or working on large data sets, Seaborn can make your visualizations not only informative but also visually appealing. So before we deep dive into this video, let's discuss the agenda for this video. First, introduction to Seaborn, where we will begin by understanding what Seaborn is and why it is so popular for data visualization. Second, key features of Seaborn. Next, we will take a look at some of the main features that make Seaborn stand out, such as built-in themes, color plates, and its capability to work seamlessly with pandas data frames. Third, basic plot types. There are various types of plots Seaborn can create, such as bar plots, line plots, scatter plots, and histograms, and many others. Customization options. We will also see how Seaborn makes it easy to customize plots, including how to adjust titles, labels, legends, and colors to make your visualization more informative and appealing. And then practical demo. Finally, we will walk through a hands-on demonstration where we will create a few basic plots using Seaborn and customize them to meet our needs. By the end of this video, you will have a clear understanding of how to use Seaborn to make your data visualization not just informative but visually attractive as well. So let's get started. So myself is Fanil Gajjar and I will be introducing you to Seaborn. So first of all, what is Seaborn? We already have Matplotlib. Then why do we use Seaborn? Seaborn is a Python library built on top of Matplotlib, designed specifically for making statistical graphics. It simplifies creating complex visualizations and makes it easier to interpret large datasets. Seaborn comes with built-in themes and color plates, allowing you to create beautiful, easy to understand plots with minimal effort. Now, why do we use Seaborn? In data analysis and machine learning, it's not just about running algorithms or crunching numbers. Visualization plays a crucial role in understanding patterns, trends, and insights hidden in your data. Seaborn helps bridge this gap by allowing us to quickly create attractive and informative plots, making it easier to understand our data at a glance. But why Seaborn specifically? Seaborn offers several advantages over other libraries like Matplotlib. First, it's designed to work seamlessly with pandas data frames, which makes handling data easier. It also has a higher level abstraction for creating complex plots like heat maps, violin plots, and pair plots, which would be more difficult to implement with other libraries. Plus, it automatically handles statistical aggregation, making tasks like visualizing distribution and relationships between variables much simpler. So in short, Seaborn is perfect when you need to create visualization that are both informative and visually appealing with very little code. So whether you are exploring data for insights or presenting results to others, Seaborn makes the process much easier and more efficient. So in this video, we will explore its features, and by the end, you will have a strong understanding of how to leverage Seaborn for your own projects. So first, we will look at how to install Seaborn. To install Seaborn, you can use the Python package manager pip. You can open your command line interface and run pip install command, pip install Seaborn. This command will download and install Seaborn along with any dependencies it needs. If you are using a Jupyter notebook, you can also install Seaborn directly from a shell using following command: pip install Seaborn. After installation, you can import Seaborn in your Python script import Seaborn as any other name like SNS. Now that we understand what Seaborn is and why it is so useful, let's dive into the first type of plot, line plots. What is a line plot? A line plot is one of the simplest and most widely used types of plots for visualizing data. It's ideal for showing how a variable changes over a continuous interval, typically time. For instance, line plots are great when you want to show a trend, like how a sales, temperature or stock prices changes over months or years. In a line plot, each data point is represented as a point, and these points are connected by a line. This connection helps us visually understand the overall trend or pattern in the data. Line plots are particularly useful when you want to highlight continuous data over time or another consistent variable. So, why use a line plot? The biggest advantage of line plots is that they clearly displays changes or trends. If you want to compare different sets of values over time or just see the ups and downs of a dataset, line plots are the go-to tool for that. They help make trends, patterns, relationships in your data more visible at a glance. For example, if we have data showing the monthly sales of a product, a line plot will help us easily see how sales are increasing or decreasing month by month. So now we will look at how to create a line plot in Seaborn. One of the best things about Seaborn is how simple it makes it to create such visualizations. You can create a line plot with the line plot parenthesis function in just one line of a code. Let's walk through an example. So as we can see in example, first we import the necessary libraries such as Seaborn for visualization and matplotlib for displaying the plot. Step: we create a simple dataset where we have two variables, months and sales. These represent the sales figures over the first 6 months of the year. Then we use Seaborn's line plot function where the x parameter represents the months and the y parameter represents the sales value. The data parameter ties it all together by specifying the dataset to use. Finally, we use plt.show function to display the plot. So, what do we observe from this output? In the resulting plot, we see how the sale changes over time. The line connecting the data points helps us visualize the trend. In this case, we can see that sales generally increase from January to June with a slight dip in April. So, now we are going to know how to customizing a line plot. One of the strengths of Seaborn is how easily we can customize our plots. For instance, if you want to make the data points more prominent, you can add markers to the plot. If you have multiple lines to compare, you can add another set of data to the same plot. Let's look at how we can add markers to our line plot. Here we added marker is equal to O character, which places a circle at each data point, making them easier to identify. This small adjustment helps emphasize each specific data values while still showing the overall trend. We can also add multiple lines. What if we want to compare two sets of data, like sales figures for two different products over the same period? We can easily do that by adding another line to the same plot. Here's how. So in this code, now we have two lines on the same graph, each representing the sales figures for product A and product B. We have used different markers, circles O for product A and squares S for product B, so that the two lines are visually distinct. This kind of comparison is extremely useful in businesses or analytics to see how two different items, categories, or trends behave over time. To summarize, line plots are one of the most effective ways to visualize trends and patterns in continuous data. With Seaborn, creating these plots is easy, and you can customize them to meet your specific needs. Whether you are plotting a single trend or comparing multiple variables, Seaborn's line plot function makes the process both simple and flexible. We can clearly observe the output for the above script. So, line plots are particularly useful when you are working with time series data or when you want to highlight trends between variables over a continuous scale. Now that we have explored line plots, let's move on to another powerful tool, another powerful type of visualization, scatter plots. Now, what is a scatter plot? A scatter plot is used to visualize the relationship between two continuous variables. It helps in identifying correlations, patterns, and trends between the variables. Scatter plots are especially useful when we want to determine whether changes in one variable affect the other. For example, imagine we want to see if there's a relationship between the number of hours a student studies and the scores they achieve in an exam. A scatter plot is a perfect choice because it allows us to plot each student's data point and observe any correlation between the two variables. So, why use a scatter plot? Scatter plots are particularly valuable when you want to explore relationship between two numeric variables, identify whether there is a positive, negative, or no correlation, detect clusters or groups of data, spot any outliers, data points that are far away from the general trend. For instance, if you are trying to understand how an increase in study hours impacts exam scores, a scatter plot will clearly show the trend. If the plot shows that as study hours increase, the score also go up, you can infer a positive relationship. So now we will look at how to create a scatter plot in Seaborn. Seaborn's scatter plot function makes it easy to create these plots. Here we can see in this example. We import Seaborn for creating the plot and matplotlib to display it, as we have discussed in line plots also. Then we create a simple dataset with two variables, hours studied and exam score. Each observation represents a student's hours studied and their corresponding exam score. Then we use Seaborn's scatter plot function to create the plot. The x parameter represents the number of hours studied and the y parameter represents the exam score. Then finally we use to display the scatter plot plt.show function. So what do we observe from this example? In this scatter plot, each dot represents one observation, a student. You will notice a clear upward trend which suggests that as the number of hours studied increases, so does the exam score. This indicates a positive correlation between these two variables. Now we will see how to add a third dimension. One of the great features of Seaborn is its ability to encode additional information in the plot using the hue parameter. This allows you to color code your data points based on another variable. Let's say we also have data about the gender of each student and we want to see if there's a difference in study habits and scores between males and females. Here's how we can modify the scatter plot to add a third variable. We can see in this example we added a third variable, gender, to our dataset, which categorizes each student as either male or female by using the hue parameter in the scatter plot function. we assign a different color to each gender. This allows us to visually differentiate between male and female students in the plot. So, what does this plot show? In the resulting plot, you will notice that each point is color coded based on gender. This helps in understanding whether there's any visible pattern in exam scores or study habits between male and female students. You can easily spot if one gender tends to score higher or study more than the other. So, scatter plots are a powerful way to visualize the relationship between two or more variables. They are flexible and can be customized to add more information through color or marker styles. In Seaborn, the scatter plot function makes it easy to create these visualizations, giving us insight into trends, correlations, and even outliers within our dataset.